Limits at infinity. Knowing the answer if the numerator and denominator are polynomials is really trivial. Here is the recipe. The limit as x goes to infinity of one polynomial, say a n x to the n plus lower terms. That is a constant times x to the n minus 1 plus a constant to the x to the n minus 2 all the way down to a1 x to the 1 plus the constant a0, all divided by, say, bm x to the m plus a constant times a lower power all the way down to a constant times x plus a constant. Now, this is what it's going to equal. It's going to depend upon the degree of the numerator and denominator. It's going to be outright 0 anytime m is bigger than n. It's going to be the division of the two leading coefficients if m equals n. And it's going to be plus or minus infinity if the degree of the numerator is larger. And you get the sign, the plus minus sign, from the sign of an over bm. If that fraction is negative, then it'll be negative infinity. If it's positive, that fraction, then it'll be positive infinity. Just divide those two numbers and use that sign. Okay, so a couple of quick examples, and then I'll show how to do it like probably your teacher wants you to do it. Suppose you have the limit as x goes to infinity of 3x to the 7th plus 4x cubed plus 7x minus 9, all divided by 4x to the 9th plus 3x to the 5th minus 2x. That's the leading term on the top. That's the leading term on the bottom. The lower terms don't matter. If x is equal to this really, really large number, okay, if somebody owed you this amount of money raised to the 7th power, this has 3, 6, 9, 12, 15, 17 zeros. That's 10 to the 17th to the 7th. That's 10 to their, I think, 119. That's 1 followed by 119 zeros. Okay? Times 3. Now, let's look at this one. If you have x to the 4th, and x is 10 to the 17th, raised to the 4th is going to be 10 to the 68. This number is so much bigger than this number. And if you want to say, no it isn't, you're absolutely right. Let's add some more zeros to this number. So maybe it's x to the 117. So I guess that's going to be 10 to the 819. It's going to be 1 followed by 819 zeros. And this is only going to be 468. They differ by almost around 3, actually I think it's exactly 351 digits. This number is so much bigger than that number. And again, if you say no it isn't, well, I'll make x even bigger. Maybe it'll have 417. And whatever that power turns out to be is and whatever this power in the bottom whatever this power turns out to be when you multiply it by 4, this power in the numerator is going to be so much bigger than that power in the denominator. Okay, so these terms really don't matter. Same with the bottom. The bottom line is the degree is larger in the denominator. And by the recipe right above, we get 0. You get 0 if the degree of the bottom is larger. So that's pretty simple. You don't have to really do anything. All you do is look at the degree of the numerator. You look at the degree of the denominator. The degree of the denominator is larger. You say 0, and you move on to the next problem. Now, your teacher may not allow you to do this. He or she may want you to show more work. But the nice thing is that you can read off the answer and then show that it's true. The limit as, say, x goes to infinity of negative 7x cubed plus 2x minus 13x to the 7th plus 9 all over 2x to the 3rd minus 4x to the 5th plus 13. Well, the degree of the top is 7, there it is, and the degree on the bottom is 5, there it is. The degree on the top is larger, so it's going to be plus or minus infinity. How do you tell? You divide the terms that had the x to the 7 and the x to the 5th. Minus 13 over negative 4 is positive. You just want the sign, and that's the sign that goes in front, and that answer is positive infinity. Since the degree on the top was larger than the degree on the bottom, the answer is going to be infinity or negative infinity. Look at the sign of the division of AN over BM. Well, suppose you have this problem. The limit as x goes to infinity of negative 7x to the 5th plus lower terms. X to, maybe plus 3x to the 4th plus 3x minus 9. And on the bottom, you have, say, 3x to the 5th plus lower terms, like plus or minus 2x to the 4th plus 2x minus 11. The bottom line is the degree of the top is 5, because though they're lower terms, and the degree of the bottom is also 5. So then all you do is divide by those two numbers. If they both say we're negative, then you should write 7/3. Don't leave the answer like that. But up to that, there's the answer. Now, let's start showing the work, because maybe that's what your teacher wants. But the point I'm making is, A, if your teacher doesn't want you to show work, well, then you can read off the answer. If your teacher wants you to show the work, well, that's good in my opinion, but at least now you know what the answer is. So if you don't get that answer, try to figure out how you can get it to be that answer. The limit as x goes to infinity of 3x to the 5th minus 2x to the 4th plus 13x plus 11x to the 10. This is all divided by 13x to the 4th minus 12x to the 11th. Well, the degree of the top is 10, so the largest power of x. The degree of the bottom is 11. We know it's 0. Maybe you hide that. You don't write that. But you know it has to be 0. Now, between the 10 and the 11, you pick the smaller one, which is 10. So what we're going to do is divide we're going to divide each term by x to the 10th, the smaller of the two. Okay, all over 13x to the 4th minus 12x to the 11th. And we divide each and every term in the numerator and the denominator by x to the 10th, the smaller of the two leading powers. And then what we get is this is equal to the limit as x goes to infinity of. This is 3 over x to the 5. I want to write this a little lower. And even bigger. So we get 3 over x to the 5 minus 2 over x to the 6 plus, I subtract the larger power from the smaller power and I put it in the place of their larger power, plus that's just going to be 11 all over 13 over x to the 6th minus 12x. Well, this goes to 0, this goes to 0, this goes to 0, this just stays 11, this goes to 0, and this goes to infinity. That's 0. (11 over infinity is 0. I showed my work. Let us try another problem where we show our work. Suppose we want the limit as x goes to infinity x goes to infinity of 3x cubed minus 2x plus the number 5 all over 4x to the 6th minus 5x cubed plus 2. The leading power on the top is 3. The leading power in the denominator is 6. The denominator has the larger power, so we get 0. Okay, but let's show our work. Again, those are the leading powers. The smaller of the two is x cubed. So this is equal to the limit as x goes to infinity of 3x cubed minus 2x plus 5 over x cubed divided by 4x to the 6 minus 5x cubed plus 2 all over x cubed. So basically, I'm just taking the numerator and I'm taking that fraction, I'm multiplying the top by 1 over x cubed, and I'm multiplying the bottom by 1 over x cubed. Well, that's 1. Numerator and denominator are both 1. Okay, let us do this division now. This is equal to the limit as x goes to infinity. When I divide that by x cubed, I get 3 minus. When I divide that by x cubed, I get 2 over x squared plus 5 over x cubed. And then do the same thing to the denominator. Divide this by x cubed, I get 4x cubed minus, minus 5 plus 2 over x cubed. Well, the numerator just goes to 3 because these go to 0. Those go to 0. This just goes to 5 and that goes to 0. Well, this goes to infinity. So we're going to get 0. 3 over really, really large is 0. I get the 3 from here. That goes to 3. 3 minus 0 plus 0 is 3. And 3 divided by infinity plus silliness, because infinity isn't affected by adding 5. Infinity plus 5 is still infinity. Okay, that's that one. Let's try a couple more. Suppose you were asked to find the limit as x goes to infinity of 7x to the 5th minus 2x cubed plus 4, and you divide this by 3x to the 5th plus 4x to the 4th plus 2x. Since the degrees of the numerator and denominator are equal, they equal to 5. So the answer is simply 7/3. Okay, now we know the answer. Notice we got the answer we were supposed to in the last problem. Now let's make sure we get 7/3. So I take the numerator and then the denominator, and I divide them by, well, in this case we only have x to the 5th. We only have x to the 5th. So the smaller power of those two is x to the 5th. And this is the limit as x goes to infinity. If you divide those two, you get 7 minus 2 over x squared plus 4 over x to the 5th. In the bottom, you get 3 plus 4 over x plus 2 over x to the 4th. That goes to 0 as x goes to infinity. This goes to 0. 7 minus 0 plus 0 is 7 for the top. This goes to 0. This goes to 0. 3 plus 0 plus 0 is 3. And yep, we got the answer we wanted. So we know we didn't make a mistake. Let us try one more. Suppose we have the limit as x goes to infinity of 3x to the 6th plus 2x minus 11 all over 22x to the 4th plus 3x cubed plus 9x. Well, the degree is larger in the top, so the answer is going to be infinity plus or minus. When I divide those two numbers, it's positive, so it's going to positive infinity. So let's make sure we get that answer. So this is equal to the limit as x goes to infinity. We do something to the numerator. We do the same thing to the denominator. And the thing is, what is this common thing that we're going to do? Well, the largest power is 6 and 4. We divide by x to the 4th. We get the limit as x approaches infinity of 3x squared plus 2 over x cubed minus 11 over x to the 4th. That's the numerator. The denominator is 22 plus 3 over x plus 9 over x cubed. As x goes to infinity, these terms go to 0. These terms go to 0. This just goes to 22, but the top number goes to infinity, positive infinity. Now, here's what happens. The numerator is infinity plus 0 plus 0. That is infinity, positive infinity. And the bottom, it goes to plus 22. Since those signs are both the same, the answer is infinity, just like we said we would get. Now, let's change this up a little bit. And we're only going to do one example because there's really no difference here. If x is going to negative infinity of some function, you may say, oh boy, now we have to have a rule, what I call the recipe for when x goes to negative infinity. No. Just let x go to infinity, but calculate the limit of f of negative x. This is key. So if I ask you, here is your example, the limit is x goes to negative infinity of 3x squared minus 4x plus 5 all over 4x cubed minus 2x plus 9. Well, this here is f of x. Well, I want to go from the limit as x goes to negative infinity to the limit as x goes to positive infinity. Now, that's f of x. I want f of negative x. Oh, you mean wherever I see x, I should put negative x? Yeah. Absolutely. So you have 4 times negative x cubed minus 2 times negative x plus 9. Let us calculate that more carefully. Negative x squared is x squared, so we have 3x squared. Negative 4 times negative x is positive 4x plus the 5. Negative x cubed is negative x cubed times 4 will be negative 4x cubed. A negative 2 times a negative x is a positive 2x plus 9. Now, real easily, we have a problem that we understand. We have the recipe for this. The degree in the numerator is 2. The degree in the denominator is larger. So we're done. The answer is 0. But again, sometimes teachers want you to show the work. So we have the limit as x goes to infinity. We have this for the numerator. We have this for the denominator. And what we're going to do is divide numerator and denominator by, well, of the two larger powers, 2 is the smallest. So we divide by x squared. We do that division, and then we try to take the limit. We get 3 plus 4 over x plus 5 over x squared for the numerator. In the denominator, we get negative 4x plus 2 over x plus 9 over x squared. Now, lots of this will be going to 0 as x goes to infinity. Anything that has an x in the denominator is going to 0. So the top is going to 3, and the bottom is going to infinity, negative infinity. And if you take the number 3 and you divide it by a really large number, fine, you will be a little bit less than 0. But at the limit, you'd be exactly 0. Hey, this completes the video for limits at infinity.